In this lesson, you're going to be able to apply the three basic trigonometric ratios, which are sine, cosine, and tangent, to actually solve problems. So you'll be able to find unknown side lengths of right triangles and unknown angle measures of right triangles. So we have already learned how to find unknown lengths when we have our special right triangles. Remember, that's the 45, 45, 90 and the 30, 60, 90. But what do we do when we have a triangle that's not considered a special one, like is pictured here? It's just a 39, 51, 90. So we can't apply those special triangle rules to it. That's when we write a trig equation. Now the format you're going to be writing your equation in is at the top of your notes there. So this is the pattern you're going to be following every single time you write an equation. So you're always going to start with a trig function. Remember, we only have three, and it's sine, cosine, and tangent. We do not call that sin, cos, and tan. Just like we would never read this answer as 12, right? We say 12 feet. We don't try to pronounce the approximation. So same thing here. We don't call that sin, cos, and tan because that's what the abbreviation looks like. We still use the complete words sine, cosine, and tangent. So you're going to have one of those trig functions that you're going to be taking of an acute angle. So we're only using trig for right triangles. So you have the right angle that you're never going to write the trig function from. It's always going to be one of the other two angles, and remember they have to be acute because they have to add to get the other 90 degrees of the triangle. So you're going to be looking from one of their perspectives when you're writing your trig equation. So sine, cosine, tangent of an acute angle, and then you're going to set that equal to the ratio of the two sides determined by which trig function you're using. So we know if we use sine, we're going to use opposite over hypotenuse as our ratio on the other side of the equation. If we use cosine, we're going to use adjacent over hypotenuse. If we use tangent, we're going to use opposite over adjacent. So let's look at number 1 in our notes. It says to set up a tangent equation to find the distance across the pond. So we know we're going to be using the tangent function and that we must do so from an acute angle's perspective. So we have the right angle that we never write a trig function from. We have to use one of these angles. Now it does not matter which one you use. So you can either put 39 here, or I'll write it the other way as well. You could put the 51 there. Those are both acute angles, so you could use either one. And then you're going to set that equal to the ratio of the two sides. Now remember, tangent is opposite over adjacent. You can always write your SOHCAHTOA at the top of your paper every time you're doing trig as just a reminder. So tangent is opposite over adjacent. So if we're looking from the 39 degree angle's perspective, the opposite side is labeled as AB. That would go in the numerator of my ratio. The adjacent side to the 39 degree angle would be side D. We are not using the hypotenuse when we do tangent. If we did it from the 51 degree angle's perspective, these would switch. So from the 51 degree angle's perspective, the opposite side is the D, so that would go in your numerator. And the adjacent side is the AB. Again, we're not using the hypotenuse. So it depends on which angle's perspective you're looking from as to what your opposite over adjacent ratio will look like. Now we can't solve either one of those because they both have two unknowns. So in order to solve, we would either have to know what AB is or what D is. But since both of those are unknowns, we cannot solve at this point. All right, so let's look at question 2 through 4 in your notes. We're using the reference triangle of a 30, 60, 90. We just got finished looking at our special right triangles. And the first thing we're going to do is find the sine of 60 degrees. So now that we know what sine means and we know our special right triangle ratios, we know how to set up that reference triangle, we should be able to write that ratio. So we know sine is simply the opposite over the hypotenuse. And we're looking from the 60 degree angle's perspective. So here's our reference triangle. Remember, that shows the 2-to-1 relationship between the short leg and the hypotenuse, and multiplying by the square root of 3 to go from the short leg to the long leg. So from the 60-degree angle's perspective, the opposite side would be the square root of 3, and the hypotenuse is always across from the right angle is 2. So we're going to use our calculator, and we're going to find the decimal approximation to that, rounded to the nearest thousandth. Now remember, I'm not sure if we talked about this in the first lesson or not, but anytime you do trig in your calculator, the mode will matter. But right now we're not doing a trig key. We're just simply putting in the square root of 3 over 2. So it doesn't matter what mode we're in on our calculator. So I'm just going to press the second key and x squared to bring up my radical and put in the square root of 3. Now the divided by 2 is not under the radical, so make sure you press the right arrow key to get out of the radical before you press divided by 2. And we want that rounded to the nearest thousandth. So let's review our place value here. That 8 is in the tenths, 6 is in the hundredths, the second 6 is in the thousandths. So remember, look next door. Next door is a 0, so if it were 5 or higher, we'd round that 6 up to a 7, but it's not, so that 6 stays a 6. So to the nearest thousandth, that would be 0.866. So you can either put on your notes 0.866 or put the 0 in front. Either way is fine. But remember, that's an approximation. So I'm going to use the approximately equal to symbol because we did round for that. Now we're going to look at using our calculator to find the sine of 60 now. And so now the mode really does matter in your calculator. So you can see the mode button is the one to the right of the blue second key here. If you'll click mode, the default mode is in this third, or it's actually the fourth down here. It may be the third or fourth on yours, I'm not sure, but it has highlighted radian. So radians are a different way to measure angles, and that's used in higher math and science classes, and we will probably talk about radians before the end of the year. But we have only been measuring angles in degrees up to now, and so we want our calculator to be in degree mode when we do trig. Now when you do regular math like 3 plus 2 or 8 divided by 4, that does not matter what mode you're in. It only matters when you do trig. So you're going to scroll down and to the right and highlight degree and press enter. So my enter is down here. So now it's in degree mode. Now to get out of this, do you see quit above mode in blue? If you'll just press second mode, you'll get out of that screen. So now I'm going to type in the sine of 60. So my sine key is here. You can see all three of the trig function keys, sine, cosine, and tangent, all in a line right here. I'm going to press sine, and then I want sine of 60. So I'm going to type in 60. Now notice whoops, I put a decimal, didn't I? Can't see my 0. There it is. Notice it has an open parentheses here. It really doesn't matter if I close the parentheses here or not, because I'm not going to type anything after it. But if you're OCD like me, you just like, if you have an open parentheses, to see a closed one as well. But I promise it does not matter at all. So we're going to press enter, and what do you see? Those are exactly the same thing, aren't they? So the sine of 60 is the square root of 3 over 2, which is that 0.866. Same thing. And I'll just show you real quick. If I did sine of 60 and didn't close the parentheses, I get the same thing. So you get the drift on that. So on number 4 in your notes, you should have gotten 0.866 as well on it. Now here are a couple of things to make sure that you understand about using your graphing calculator. Again, make sure that you're in degree mode. So if you clear your calculator by pressing second plus 712, you're going to have to go back to the mode and change it to degree every single time. So you can see here, if I do second plus 712 and I go back to my mode, do you see it highlights radian again? So I would have to go back and highlight degree and get it in degree mode. Now, if I'm just typing 3 plus 2 and I press the clear button to clear that off my screen, that did not change the mode. You can see I'm still in degree mode. So pressing this clear button doesn't get you out of degree mode. It's just when you do a hard reset using second plus 712 that it'll go back to the default setting. So on your calculator, the sine, cosine, and tangent buttons are going to be used to find missing side links. The ones that are above them in blue, it looks like they're raised to a -1 power. That looks like sine to the -1 and cosine to the -1 and tangent to the -1. But those are called inverse trig function keys. This is inverse sine, inverse cosine, inverse tangent. Okay, so we've talked about inverse operations like addition and subtraction. They undo each other. Well, these are the functions that undo the regular sine, cosine, and tangent. We use the inverse keys when we're trying to find the measure of a missing angle in a right triangle. All right, and then another note is to notice that since the hypotenuse is the longest side of a triangle, your calculator will always give you an error message if you try to use inverse sine or inverse cosine of anything greater than 1. So for example, if I tried to ask my calculator, what is the inverse sine of 13 over 12, it's going to give me an error. And the reason for that is, remember, sine is opposite over hypotenuse. Well, it's not possible to have an opposite side that's bigger than the hypotenuse. So that's why it's going to give you an error message on those. All right. So just some information about trigonometry. It literally means triangle measurement. So trigonometry can be used in lots of ways. With triangles, we are learning what's called basic right triangle trig. There is trigonometry that works on non-right triangles. I think I mentioned it already. We hope to get to that at the end of the year. But you will also look at more extension of trigonometry in Algebra 2 and in Pre-Cal, and of course use it in any higher math from that. So trigonometry was actually developed by ancient Greeks many, many years ago, as you can see, 200 BC. It was initially used in the study of astronomy, and obviously if you're doing astronomy, that has to do with the stars and the space and all that stuff. You're finding distances that obviously cannot be directly measured, and so trigonometry is a way of doing indirect measurement. Since they did not have TI-84s, they used trig tables, and that's what I used when I was in high school. Miss Wilkins wants you to know that she's much younger than me, so she did not use trig tables, so just throwing that out there. But we would have to look up the sine, cosine, and tangent of numbers using the tables. So this does kind of help you understand that when you take the sine of 60, or that's what we just did in our example, that it is a number. Sine is a operation happening to a number. So sine by itself doesn't have a value. It's like a square root symbol doesn't have a value by itself. It's an operation being done to a number. So it's something that you can look up. We're going to go back to the problem about Carlos wanting to stabilize a tree. Remember in the previous time we looked at this, we were applying our special right triangle rules, which we could still do here. If we were trying to find the height on the tree here, 3 feet is the short leg, so we would multiply it by the square root of 3 to get the height here on the tree being 3 square roots of 3. And then the amount of the wire needed, which is C, would be twice the short leg, so it would be 6 feet. But we're going to look at how we could answer this question using trigonometry instead of using our special right triangle rules. So I'm going to mark on the notes here. This is the first thing we're going to do is find the height on the tree. So the acute angle that's given is 60 degrees. In respect to that 60-degree angle, the side I'm trying to find is the side that is opposite it. And the side that I know in respect to the 60-degree angle is the adjacent side. And so I would want to use whatever trig ratio uses opposite and adjacent. So remember I told you could write this on your table, on your paper. Opposite and adjacent means I need to use a tangent ratio. So we would set up our equation using the pattern we talked about up here. We would have tangent of that acute angle equaling the opposite, which is h, over the adjacent, which were giving us 3 feet. And we'll finish that in the next video.